All right, for chapter 16, we're going to look at natural language processing. Now we know a little bit about recursive neural networks. We can use those to start with some of this natural language processing, because natural language often has the same sequence of words or syllables or sounds, and we don't know how long it's going to last, and we still want to process it for the data. Um, so the book starts talking about the Turing test and chatbots, and again, we want to try to create a ability to both understand natural language and also generate natural language, and we'll talk a little bit about both. Um, this does mention that the second part of this chapter looks at the attention mechanism and some new transformer networks that are off. Two of the well-known ones are BERT and ELMO. There's their acronyms, so sometimes people refer to them as the Muppet networks. We're going to save this second part for the last unit, where we're going to talk about generating both um, these sorts of networks, auto generation networks, and also using convolutional neural networks to generate new images. Um, but we're going to start here with just simple generating Shakespeare or other text. We're going to feed some text into a character-based RNN, recursive neural network, and have it then generate new text. Kind of like in the last thing where we looked at the time series and have it generate the next value in a time series. We're going to treat characters like the same way for this. So we're going to get our training set. This used Shakespeare, but actually in our version, let's import these libraries. Check on. You can choose from a couple different texts. We have the Shakespeare text, we have Alice in Wonderland, we have the Bible, and we have the Wizard of Oz. So these are 4 different texts I have stored out there. So you can just choose whatever URL. I'm going to choose the Wizard of Oz, it looks like here. And then we'll load in this text in to our system. So now we're going to load in our text, and then there's going to be a fair amount of pre-processing we're going to have to do. First, we're going to have to assign each character a token or a number. So you could think of like an ASCII character value of this, or a Unicode if you're familiar with those. But again, we want to limit the size of this, so we're going to assign unique tokens. So you can say we'll just use A is 1, B is 2. But we're going to have the system do this automatically, and we'll find that there's a fair amount of other characters, punctuation, and stuff in our text. And so there's a tokenizer that'll look through our text and assign a digit, an integer to each of the letters for that. So now that we've read in our text, we're going to tokenize it here. So the word Gibbons is tokenized with this. We generally push it all to lowercase, and then if we look at these numbers, the tokens associated with that, the characters associated with that is Gibbons here. There are 55 distinct characters in our text, including spaces and punctuation and things like that. I'm using, I choose the Wizard of Oz text, and so there are 200,000 characters. So this is a relatively long text. So the next thing we want to do is break this text into parts, split the data set. So we certainly can't, what we want the computer to do is look at a sequence of characters and then predict what the next character is. And so we want to feed it a sequence of characters. So we're going to chop our data set into multiple what are called windows here for that. So we're going to use this window and then shift it forward. So we're going to look at like the first 100 characters and have it predict 101st character. And then look at the characters 1 through 101 and predict 102nd characters and stuff like that. Your book has a kind of a good kind of view of this. If this is our character sequence, here's our first window, the first 100 characters. The second window is shifted forward 1 more, and the next window is shifted forward 1 more, and then we're always having it then predict what the next character in the sequence is. So we have our input and in our target. And then we're going to, once we have all these windows set up, we're going to shuffle them around. So this we'll just see a set of characters, and then learn to predict the next character, and then learn to do another set of characters and predict the next another one. So so that's what this is. And again, I'm not going to go too much into this Python code. In fact, it changes fairly. Since the last time I taught this, they've developed some new techniques. We used to do this all by hand, but now there's these tokenizers class that does a lot of this for us. So it'll scan through our text. We're going to set aside 10% of our text for testing later on. And we're going to feed this all into this tensor, what is called a TensorFlow data set, which is a relatively new structure for handling these stuff. And so again, our window size is 100, and so our window length is actually 101, because the last character is going to be the one we're going to predict. And then we're going to shift each window ahead just one, so we get lots of windows here. And then we're going to break this all up into batches, shuffle all the data, break it up into batches of 32 sequences at a time, and then set up our data set. And so our data set, we're going to predict this actually takes our window and predicts everything but the last character. I mean, uses everything but the last character for input, and then the output is the last character that we're going to print out. And again, you don't have to worry too much about this Python. We're not. If you want, you can try this out and try to decipher what this does. But again, it's not critical to the machine learning process. So once we have that set up, we have 32 batches. Our inputs is 32 batches, each 100 characters long for this. And our output is, again, 32 batches, each 100 characters long. And again, your book walks through this process pretty well, code, if you want to look through this. Now we're going to actually build the RNN. We're going to use these gated recurrent units, GRUs here. And then we're going to add something called dropouts, which are in time. So the recurrent network will feed back and will lose things. And this will help us generalize a little bit for this. So it's especially kind of drop out for here. So here we're setting up our sequential network, 2 layers of these GRUs for this, each 128 character or units wide or long. And our input, we're feeding in our input 1 character at a time. We have this special dropout for these units here. Well, normal dropout and a recurrent dropout. So this is dropout going forward, and this is the dropout for the recurrent connection coming back into this unit. So we have 20% dropout on both, to try to force this to generalize a little bit more. And our dense unit is, our activation is at the end of softmax. We have to use something called a time distributed version of this, because again, we're going to feed in sequence again. We have this return sequence equals true. So we are feeding in a sequence of characters to this unit, but it is feeding that its whole sequence onto the next layer. So this layer sees a whole sequence of characters coming in 1 character at a time for this, and then 1 new character added to this sequence as it goes. So then we'll compile this and build this network. And then once it is set up, we can have it generate text for this. So the training for this is going to take quite a while. So right now, by default, I have this set up for training for a single epoch, which isn't going to be enough to do anything very useful, but it's still going to take a long time. You should really, again, depending on how which of the training sets you use and how long it is, you should be training this for an hour or so if you have time to do that. By default, again, I just have this training 1 so we can show you the rest of it. But to get really good text, you should be training it longer. So I'm going to let this run, and then we'll go on from there. Okay, so I've finished training. I've only, again, trained it for about 10 minutes with one epoch. You should maybe, depending on your text, try to do more epochs. So you can get more training here. So I don't expect great results with this limited amount of training. Okay, so next thing we're going to do is have the network generates a new text. So we're going to write a little method called pre-process. We're going to feed it some text. That's all it's going to do is what we've done before. It's going to tokenize the text, change all the characters to numbers, and then set that up and return that to our system. And then what we'll do is in our training here, we'll pre-process some text. So we're going to feed in this line, how are you? And then we're just going to say Y, O, and hopefully the next character should be Y. Hopefully it's learned that. And then we're going to feed that text, those tokens, into our network and predict the next class out here. And then we're just printing that out. What our next code in order to do that. So this returns a number, and again we have to convert that token into a text character. So we're going to convert that character back into the predicted character here for this. And when you run this, now one thing you'll notice when running this is that this text in this is code right from the textbook, and it's a little bit out of date already with the new TensorFlow. So this predict class is being phased out next year. So you always get this warning about this, and then you do it. Now, if you run this again, you won't get the warning. Just the first time you run it, it gives you a warning for that. And so given this how are y u o, the next character predicts is y. So it is actually predicting a relatively good character for this. So once we have this set up, we can actually, as the book describes, generate texts here. We can have this new character, next character method call. So we'll process some text, have the model predict the next character, and then print that out. Now, if we're always just taking the most likely character, what happens is the network doesn't do very well. It gets caught into loops of words for this. So I'm running this, and again, one thing to notice, we're predicting the next 50 characters, and again, it gives you us a bunch of these warnings that this make predict is being taken out. And again, if I run this again, those warnings will go away. But I'm just leaving those in for now because we still have a year before this function is removed from the API, so it still will work for a while. So we're trying to predict the next character, but again, if we just predict the next character, we tend to get into loops where we're not getting very good text. So we're going to introduce a little bit of randomness, and we're going to introduce a temperature variable here for this. And so we're going to look at, it predicts how probable the next character is, and it's just going to grab one of the more probable characters, but not always the most probable character for this. So we don't get in these loops directly. So now if we have this run, this is generating the Tin Man, a stuffed, the Scarecrow, and so it's actually getting, again, it's generating these character by character, which is pretty good. So we're actually getting words generated here. Sentences, not so much. Again, we haven't trained it very much, so it hasn't learned long temporal things like sentences and that sort of stuff. But it's learning the basics here, which is actually very good. And again, so when we call this, we actually can feed it something called the temperature. And if we feed it a very low temperature, then it kind of ignores it and just always picks the most likely character. And here we get into this repetitive stuff. So we're getting the Scarecrow, so the Scarecrow, so the Scarecrow. So we're just repeating the scarecrow again and again because it's learned that word. So it's like an infant who's just learned one or two words and just repeats them over and over again. And again, so if we increase this temperature up to a higher value, it gets more random. I mean, yeah. So, and then at this point with this training, it's not even making real words for this. So again, sometimes you have to value. So the book uses a temperature initially of 0.2 in here, and that should generate some words. And again, we have only trained this for a short amount of time. We should really train this. I mean, if you really want to train this, I've run these for overnight training, although it's sometimes hard to get it to process that long in Colab. But you can run these overnight and then save the weights and use them again here. So that's our network for generating text. The next thing in the text book talks about stateful RNN. And so one thing what we've did with this network is we're feeding it like 100 characters and having it predict the next character, and then grabbing a random 100 characters somewhere else and having it predict the next character. There's something called, so each time we reset the network before training, and we need to feed it up to 100 characters so that it remembers some past information before predicting the next character. There's something called stateful RNNs where every time you give it some new inputs, part of a sequence, it doesn't forget the old sequence here, and then that lets you change training and then feed versions of this in, and then just feed the next one. So we can change how we train and stuff like that. But I'm not, again, wish we had time, but we're not going to worry about the stateful networks and this, how you set these up. So I'm just going to skip that section of this text. If you really want to get into this area a lot more, you should learn that. But again, it's not critical to understand this at this level. Because I want to get into sentiment analysis. So can we understand some meaning from these words? So if we are given a whole sequence of characters or words, can we understand some meaning, some organization of this? So the kind of hello world version of this of sentiment analysis is to look at the Internet Movie Database. IMDb is a collection of movie reviews and a website associated with those. And so we're going to look at those. And then we're going to try to classify a review, is it either negative or positive for that. So we're going to set that up here. So this is just the code from that. Oops. So this takes a little bit to load in this data. And I'm going to go in how this data is all set up necessarily, but we have to load in some of this overview data here. We download this, and then we have to load in this data set of the word index. So what we're doing is we were doing character based, having one character time and generating the next character. But now we're going to switch to word based. So every word will be assigned a token. We'll give a number to each word in a review and rate things on word levels. You could do this on character level, but again, you need a pretty good network to build up higher level representations, and with our limited training, that has some issues here. But again, we have to load in our data and set it up, so you'll see this taking a little bit of time to load up and run. We're only about halfway done here. Okay, so the book talks about loading up this data and talks a little bit about how it works in a paper that was done, or a couple papers about this. And then a pre-processing step here that we're going to do to review these. So again, with our reviews, we're going to have to take our reviews, feed it into this pre-processing that's going to have to break things up into words we're going to have to watch certain, we're going to try to eliminate certain white spaces and stuff like that and only focus on certain words or letters out there. There's also going to be a special character called a pad, which marks the end of a sentence here that we're going to look at. So this pre-processing is set up for this, and again, I'm not going to go into too much detail how this works. Now, in the end, there are thousands of words in our reviews, 50,000 words, in fact, over 50,000 words. We're going to limit that to the top 10,000 words because again, we have to encode all these words in some ways, and so we're going to want to limit how much input we feed to this network to 50,000. So we've got these movie reviews read in, and we can print off a sample of them. This was an absolutely terrible movie, so it's, we should be able to learn that this would be a negative review. I've been known to fall asleep during films, and so that's probably a negative review too. And in fact, the labels are both negative for these. So these are actually labeled already for us. And then again, we're going to define our pre-processing and pre-process our data for this. And then we're going to look at our words and limit our word count. So again, so if we look at something like this movie is clearly fantastic, this is tokenized to 22. Movie is 12, and because this is movie reviews, movie is a very popular word, so it's a pretty low score here. Was is 11. Words that aren't as common, like clearly, are assigned a larger number, like 944 here. And words that don't appear in our dictionary or a list of 10,000 words will be assigned number 10,000. So this fantastic is assigned 10,000. So that's how we can take any phrase here and tokenize it, assign words. That's what our pre-processing system does now, is assign those words for this. Okay, so now if we have a sample movie review out there, then we'll set it up for tokens. So this is actually the data that's passed into the database, is just a list of tokens or numbers corresponding to each word, and so we're giving each word a number and feeding that into our system. So, okay, so here's our neural network set up. So similar before, we've got two GRU networks, two of these gated recurrent units, each 128 units here set up, and when we have a special embedding layer here where we set up our vocabulary size, and that was actually, will break our data up, and so we'll actually take each of these numbers and embed it, and I think it uses kind of a one-time encoding to send this in. So we're basically sending in 10,000 units and saying which of those words are on here for this. And then we're just outputting one thing, is this positive or negative review? So we're going to feed in these words, one word at a time, have it look at the whole review, and then predict at the end, is this positive or negative for this? So training is going to take a while for this to run. And then once that training runs, we can evaluate the model. So this code will print out some sample reviews here. So here are a couple different sample reviews. And then we can use this model to predict. So we can take some test samples, these same samples up here possibly, and then we can predict if it. So and each time we feed a review into our model, it gives us a number between 0 and 1, 1 being positive, 0 being negative review. And then so here we're just checking, we're doing these predictions, checking if the score is above 1/2, we're saying it's a positive review. If it's below that, we're saying a negative review. So again, here's the actual numbers. And so some of these are very clear. We certainly know these are positive reviews here. So here's positive reviews. And we certainly know some are negative reviews, clearly negative. Some of them are a little more confusing here, like this is right in the middle. We really have a hard time figuring out that here. So this is sentiment analysis, again, where we're trying to train a network to understand words and what words mean. Now, again, you might have a question, is it really understanding words or not? Yeah, it's really not. I mean, in some ways they're not. It's just learning which words are associated with good reviews and which words are associated with bad reviews for that. Okay, so your book goes through this and talks about how this works also. So you just have to do the write-up for this. Now, it does talk about masking. This, I kind of skipped over this part, but there are certain things, the padding at the end of characters and stuff, and how that's handled. And I'm not going to worry too much about that. It's not. It's just a setting that's is set up when we set up our network, and our code does that for it. Okay, I'm not going to cover this other section on reusing stuff, and then we get in these auto encoder and decoder networks and these more attention networks. These are networks where we are going to encode sentences and decode them, and these are used a lot to actually try to come up with a better meaning of characters. And we'll do this next time, and we'll talk about machine translating systems where we'll have an English word and an output a Spanish sentence or something like that. And so I'm saving this last part of the chapter till next, the last unit. So we'll cover this last part of 16 on encoder networks and also the attention networks, which are this taking over a lot of this work with machine learning, is these attention mechanism and attention networks. So a lot of this has come out just in the last few years for that. So, okay, so that wraps up this unit.